So there are 6 questions. The first one just to explain without data. So the first question, try to explain what is quantitative variable. So quantitative variables, just the numerical values. So the variable that represent the actual data, they want quantitative. Okay, so numerical data. Qualitative variable, so the one that we just discussed just now. So variable that we create to represent different categories they want. Qualitative variable. So dummy variable, just the variable that we create supaya sederhana. So dummy variable, the variable we create to represent different categories. Question number 2. So A, consider the cross-section regression given here. So we have dependent variable income, independent variable we have education and meal. So in this case, education is the person years of schooling, so they want the education. Income and education just the quantitative variable. So income is income. Education is person years of schooling, so there's number in terms of number of years. So that one is the quantitative variables. Male is the dummy variable. So n male is equal to 1 if the individual is male, 0 otherwise. Show how the intercept changes from male compared to female. So this one, because we have one dummy variable, so this dummy variable allows us to differentiate the two categories, male and female, in terms of intercept. Because if the variable is 1, then male has additional part of intercept, beta 0 part beta 2. For the case of female, this one 0, then we only have this one. Okay, so you look at the given solution. So it's explained us for the case of the reduced equation for male as well as versus for female. So for male, we have this one. So we have intercept beta 0 plus beta 2. For the case of female, just beta 0 intercept. The slope are the same for both. The slope the same for both male and female. B. So for B, we have interaction between independent variable, education and male. So show how the slope coefficient for education differs for male compared to female. So this one, if male equal to 1, then we have intercept for male beta 0 by the slope because beta 1 education plus beta 2 education, because if this one equal to 1, so we have beta 1 plus beta 2 education. So we have the slope for the case of male, beta 1 plus beta 2. For the case of female, when male equal to 0, the variable equal to 0, so we have the intercept beta 0, slope beta 1. So the second equation only allows the model to differentiate the two categories, male and female, in terms of the slope. So now, if let's say you want to have a model that allows you to differentiate the two groups, male and female, to have different intercept and slope, what you need to do? So you need to have formula, you need to combine. So you need to add this one. This one you need to add. You need to add another interaction as beta 2 plus education and mail. So this one already determinant variable. So you need to add interaction so that the model allow you to have both to be different in the segments. Just like the example that we considered in the lecture just now. So question number 3, a large corporation firms hires financial advisors to work with clients but they are not paid commissions. When someone you hire, the salary varies depending on different factors. The following relation is used to estimate the relationship between salary paid and few key factors. So we have independent variable salary. Independent variable we have experience. So salary is just by a quantitative variable. So annual salary. Experience just of experience. So they want. So this one just quantitative variable as well. So GPA and GPA grade point. Also quantitative variable, but we have two quantitative variables. So this one is two quantitative variables, CSP, which is equal to 1 if the individual is certified financial planner, if not 0. And then we have another variable, NOCFP, that is equal to 1 if the individual is not certified financial planner and 0. So you can see there, these variables are representing the same thing. Okay, I mean redundant, just like male and female. Just like you create one variable for female and for male and another one for female. Okay, so basically you don't need to have both. So in this case, what problem that we have here, since we have beta 0 in the model, so the sum of these two will have all into 1, which is equivalent to this one. So we have perfect equality. Okay. So you cannot include both. So number 3, this regression has fallen into dummy variable trap. CFP and NO, CFP have a perfect linear relationship because if you take sum of the two variables equal to 1, no matter what, this violates the assumption that two independent variables can have a perfectly linear relationship. So in this case, basically the sum of this equal to the first column. Remember in X matrix, the sum of these two equal to 1, which is equal to the first column in your X matrix, so that we have perfect collinearity. So the regression cannot be estimated. One of these should be excluded, should be left out for regression, or if you want to retain both in the model, then you have to take out the normal intercept, beta 0. You have to exclude the beta 0. Okay. Number 4, consider the following times model which attempt to explain employment for construction workers. So we have 3 different models for us to choose. So the first one, we have employment data, dependent variable. Independent variable, we have GDP, and then we also have dummy variables that represent different seasons. So we have summer, winter, fall, spring. So for this one, if the data belong, okay, the data belong for the summer season, this one equal to 1. If not, it is this one equal to 0 lah. If the data belong to winter, collected during winter, for example, or representing data for winter, then this variable equal to 1, if not equal to 0. So meaning that for each of the observation, only one of these must be equal to 1, and the other 3 must be 0. Okay. So we have summer 4 seasons. So you can create up to 4 dummy variable for each of the seasons. But since we have, remember, since we have beta 0 here, the common intercept, if we include them for all categories, then we have the same problem like before. Sum of this, summer plus this, winter plus fall plus spring, all into 1, which is equal to the first column in your X matrix. Okay, so we have the first model cannot be used because it has fallen into the variable trap. So one variable must be omitted or excluded from computation. Second one, we exclude spring, so we only include 3. Then okay lah, because we have beta 0, then we have only 3. The third one we don't have intercept. We exclude 1, but we don't have the beta 0. Then meaning that the model is incomplete lah. because we don't have, remember, for the second one, beta 0, the common intercept represent for the one that we exclude. So beta 0 is our reference category, represent for the reference category, which is for spring. For spring, for the second model, spring is our reference category. So that is represented by beta 0. So for the model number 3, we don't have reference category, because we don't have coefficient to represent the reference category, beta 0. So model number 3 is incomplete, it's not complete. So we need to, the model we should use the number, model number 2. Okay. So why did you reject that 2? Because, so I explained before, the first one that we are track, the last one is not complete and incomplete. How will you tell the habitat in general, the season of the year does not affect employment? So you, using the second model, how to test? Because remember, for the spring, intersect beta 0. For summer, intersect beta 0 plus beta 2. For winter, intersect beta 0 plus beta 3. For intersect beta 0 plus beta 4. So you need to test whether beta 2, beta 3, beta 4 all equal to 0. Okay, not equal but equal to 0. Beta 2, beta 3, because for the case of spring, they intercept beta 0. So this model only allows the intercept to be different, but it does not allow the slope to be different. If you want to have a slope to be different, you need to have interaction, but now you have many variables, also it will be difficult to do. So if you want to perform the test, then you have to tell them you perform using the walk test. Question number 5. The following table gives non-seasonally adjusted quality data on the retail sale of apparel and accessories for the period of 1983 to 1986. So we have quality data. So now, just like we have different categories, we have 4 different categories. So we have just like season just now. Right now we have different quarter, 4 different quarters. So just like 4 different. So we want to know how different quarter affect the sales. Then you need to create that variable to present different quarter. Okay. So consider different model. You variable sales of this, and then you create that variable for second quarter. You include that variable for second quarter, third quarter, and last quarter. You exclude the first quarter. Okay. So meaning that the first quarter is represented by beta 0. The intercept, the estimate of sales for first quarter is given or represented by beta 0. And then for the other quarter, for the second quarter, the estimate of sales given by beta 0 plus beta 1. You understand, right? For second quarter, beta 0 plus beta 1. For third quarter, beta 0 plus beta 2. The last quarter, beta 0 plus beta 3. The intercept, so this one we only consider the intercept to be different across the 4 different quarters. So estimate the model. So what is the interpretation of the bias coefficient? So you have the data. So this one we have the quasi data, still data. So in order to investigate, to examine the effects of different quarter on sales, we need to create that variable first. Okay. So how to create that variable? For the time series data like this, for quality data, you can create a variable using the SEES. Okay, for example, this one. Now we want to create a variable. Let's say D1 for the first quarter, D2 for the second quarter, D3 for the third quarter, D4 for the last quarter. So you go to quick generic series. Quick generic series, and then you put D1 equal to SEES bracket 1. Okay, I show you this one. So D1 equal to this, and then after that you create another variable. D2 equal to this. So if for the case of, because this our data is quarterly data, so if use we create a variable for different quarter. So D1 for first quarter, D2 for second quarter. If your data is monthly data, then the ABUs will create a variable for different months. So you use the same command, but ABUs produce dummy variable for January, February. So you need to put 1, 2, 3 until 12. For this case, until 4, because we only have 4 quarters. Okay. So this one, okay. You see that we have only 1 for the first quarter, 0 for the rest, and then we do the same again, repeat. So we put D2 bracket 2. You have to be careful. You put this one correct value, then you get correct. Okay. So D2 only one for second quarter, 0 for the rest. And you again. D3. Then D4. Bracket 4. Here, estimate model, quick estimate equation. So we have sales, our dependent variable. Then the question asks us to have the common intercept, which is beta 0. So we put C for beta 0, common intercept. And then we have, we don't have other variable, we only have the W variable. So we have, so we have D2 space D3 D4. So we exclude D1 because if you put all, what happen? You put C and you put D1, D2, you put all, what happen? You have the perfect collinearity. So you cannot include all the variables. You have to exclude one. So that the first quarter is your reference category. Okay, so press OK, so you get this one. So now, how to interpret? You have to understand how to interpret. So C is your intercept for the reference category. So it gives you an estimate of sales for the first quarter. How about this one, D2? D2 gives you additional part of the intercept. It does not represent the whole intercept for the second quarter, but it just the additional part of intercept. So to get the whole intercept, to get the intercept for second quarter, you must add this one, beta 0 plus beta 0 plus beta 1. Okay. So you understand this one, you use this equation, you use formula, you use this model. The first quarter is given by this one. The estimate of sale for first quarter is given by this. For second quarter, beta 0 plus beta 1. Second quarter, beta 0 plus beta 1. Third quarter, beta 0 plus beta 3. So you have to add. So for the third quarter, this one plus this. The last quarter, this one plus this. Okay, to get the sales. So this allows you to test whether the difference is significant or not. There is significant difference, okay, between the reference category and each of the each of the quarter. So what is the interpretation of the various coefficient? So the average sales in the first quarter 4,768 million. In the second quarter it was higher by about, because again so the value given here represent the additional, not the whole sales estimate for the second quarter is additional. So you say the higher by this, okay, as compared to reference category. This is our reference category as compared to reference category. This one, because second quarter, this one plus this one, and this represent the additional part. So higher by about 912 million. In the third quarter, by about this. The second quarter, the last quarter is about by this. Okay. And the actual values of the intercept in the various quarters can be obtained by adding the differential intercept dummies to the base quarter value. The individual intercept values are respectively as given here. So if you this is the first quarter, second quarter, this one plus this one, you get this. For the third quarter, this plus this, you get this. Okay, the last quarter, this plus this, you get this. So for this model, how to perform the test in order to say, so let's say you are asked to test whether there is significant difference. There is significant difference in the sales for the 4 different quarters. So you need to test this one, you need to test beta 1, beta 2, beta 3, whether all equal to 0 or at least one of them are equal to 0. Understand that? So you need to test this one, beta 1, beta 2, beta 3. You can perform a walk test as usual. So if you reject, meaning that the sales are not the same for different quarters. If you do not reject all equal to 0, then you can conclude that the sales are just the same for the four quarters. Understand that? So again, this one, you need to test this equal to 0. So you go question number 2, 3, 4. Walk test, coefficient diagnostic walk test. Coefficient number 2. Number 2, 3 and 4 all equal to 0. If we do not reject, then we see that sales are just the same, which is given by the reference category 4767. If we reject, it at least one, because the coefficient, the additional part, the differential, estimate of the differential sales, if any of them, if we reject, we need that there is a significant difference now. Okay, so you see the test has still empty value, so we reject now. We need that the sales are not the same. The sales are not the same for the 4 quarters. At least there are 2 quarters that have different value of sales. Okay, the actual value. What we have estimated, I hope you understand. How you still, I hope you understand. What we have here just an estimate, but we want to perform our testing to make inference or conclusion about the true value. Okay, the true value, because this is a sample, we want to make a conclusion or statement about the population one. Okay, that's through the hypothesis testing. Whether we are confident enough to say the true sales, the actual sales, equal or not equal for 4 different quarters. You look at the numbers, there's a difference. But this one is an estimate. This one what we have just estimate for one sample. Okay. Question number 6. So you use the same data, but now you include all dummies that were for all categories. So meaning that you can include that word for all categories, but you have to take out the set. You have to remove the common intercept beta 0. Okay. So this one, let's say we this one I want to show you the alternative way of estimation. Okay. If let's say you don't want you don't want to create that variable first. Let's say you have, for example, let's say you have weekly data. So you have 52 categories. Okay, 52 categories. And then for weekly, not sure whether we can do it. But for monthly data, you can use. So this one, let's say there's an alternative way to estimate this one. How you can, instead of creating main variable first, you can directly estimate the model by using this command. Okay, so this one, instead of creating the variable first, you can just directly estimate this model. So instead of put D1, D2, D2, D3, D4, you can put and expand at quarter, but because if you do this, it will create a number for all categories. So we need to exclude one because we have C here. Since we have common intercept at 0, then we need to exclude one of the dummy. How to exclude one of the dummy? You need to add drop first. So you put drop first, it will exclude the first dummy, the first category. If you put drop last, it will exclude the last category. So you only have two options. So you have 4 quarters. Either you drop the first one, the first quarter, or you drop the last quarter. So you want to drop the last, we put drop last. Drop last. Okay. So this alternative, alternative instead of alternative to this one. Just now we use this. You put C, we put D1, D2, D3, D4. But we need to create this one like variable first. We need to generate this like variable first. But alternatively, you do not need to create a variable first. You can just directly estimate model by using this command. Okay, expand, quarter, drop first because we want D1. We want to D1, so we drop the first to D1. Yeah. So we estimate. So this one drop first. So we get the same estimate. Okay, we get the same, but the benefit of doing this is that you do not need to create that variable first. Okay, you can just directly. If you have monthly data, instead of put quarter, you put month, M-O-N-T-H. Okay. If your data is monthly, then you put, instead of quarter, you put M-O-T, month, M-O-N-T-H. Okay. Okay, now question number 6. Question number 6. So now question number 6 asks us to include the variable for all categories, but we need to exclude the common intercept at 0. So you have to estimate model. So quick estimate equation. So we have sales. And then without C, and then you can include all. So question number 6, question number 6. So it's sales without C because C for the beta 0. And then expand, so meaning that you will have dummy variable for all quarter. Okay, without the common intercept C. So basically, okay, you can include the variable for all categories, you can, but you have to exclude the common intercept. Beta 0. Otherwise, because remember your X matrix, we don't want to have. You include all that variable, then you have to make sure that the first column is not more equal to 1. So this one, okay, name equation, the previous one, equation 1, second one, equation 2, okay lah. So you compare, so this equation 2. Equation 1, equation 2. So you see the difference when we estimate the second model. So each of these represent estimate of sales for each quarter. There is no reference category anymore. Yeah, there is no reference category anymore. So each of these provide estimate of sales for each of the particular quarter. So this one, beta 1 is the estimate of sales for the first quarter, beta 2 estimate of sales for the second quarter, and so on. So you can see this one. The first quarter 4767, just like before. Okay. Second quarter, so this one equivalent to this plus this 4767 plus 900 something, you get direct estimate. Okay, direct estimate. So how you interpret, so as given here, so basically this model have assigned, we have assigned a non-variable for each quarter, but until that to provide a variable trap, we omitted the intercept term for this model. So the second, so B, to estimate the model, we have run a regression to the origin, so meaning that we exclude the beta 0, so yes. Then compare the result of the model with the previous one. So if you compare, this second model gives us direct estimate of the sales for each quarter, not only the differential. Okay, so it gives us the direct estimate of the sale. So it depends what you want to perform or what test you want to perform. If you want to compare, if let's say your objective, you want to compare whether the sales of the second quarter significantly different from the reference category, then you have to use this one. You have to use the first model. But if you just want to test if the sales are the same or not for the 4 different quarters, you can use this one as well. So if you perform a test, if let's say you want to perform a test whether the sales are the same or not for the by whether it's affected by different quarters, so you can perform the word test as well. But in this case, you perform the test, then option number 1, 2, 3, 4, all equal, not equal to 0, but all equal only. Okay. This one you just test whether beta 1 equal beta 2, equal beta 3, equal beta 4 or not. Not equal to 0, but equal only. Okay, for this model, second model. So if you perform the test, you go to walk test, option diagnostic, walk test, you test option number 1, 2, 3, 4 equal. Okay, not equal to 0 but equal. So okay, so you get the same line just like the same result like before. They say exactly the same. So p value greater smaller than 0.05, so conclude that the sales are not the same. So mean that it is affected by different quarters. Different quarters have different sales. So in terms of comparison, so as I put here, so we provide a direct intercept values for each of the quarter. We said from the previous question number 5, intercept values for second, third, and fourth quarter are obtained by adding the differential intercept. So of course, per procedure give identical result as they show. This data, if you check in detail, so you produce graph of the series, you can see that basically it has trend. So basically the better models that you should include trend as well. Okay. You can see the values of series increase. So the better model, I mean, it's not given in the question asked, but if you want to have a better model, then you have to include the trend as well. So if you estimate the model, where is the D1? B2. we estimate model by adding trend as well. Or maybe it can be done either one. You can using the based on question, question number 5 or number 6, either one. So trend, I'm not sure whether I explained to you before. For the trend, just add trend plus 1. Okay. So either one now, so let's say whether this but this one you have to put add trend plus 1. Either you use one or this one, either one. Okay. So let's say you add trend for the second one, so you get this one. So trend significant, so you have better model. So you compare maybe your IC or adjusted aspect vector. So one of the question just like your midterm test question, how to know the first part, which one better? Question number A, 1A or the last one? Not the last model. When we exclude, so which one better? You can refer to the adjusted square. Which one has higher value of adjusted square? That's how you should answer the question. That's way. So we have half an hour minutes left. Should we discuss the answer for the test, or we want to stop the lecture now? Why? Because you're not confident you answer it correctly. Okay, so we start now. But next week, I'm not sure. Most likely we'll have physical lecture as usual. But I will, if there's a lecture, then we will choose my trip. Okay. So just to remind you now, for example, the second question requires you to think, because the question not only based on what given or explained or discussed in that session. What important is everything. You have to understand everything given or explained in the lecture notes. Because in the lecture note, the question that about the redefine the variable is not. We do not have that example in that session, but it is explained in the lecture note, right? So make sure you understand everything given in the lecture note, because even the final exam, because now it's open book, so some questions must require you to think, not just simply get question from. So you have to really understand, and then you need to think to find a solution. Okay. Final exam, you do not need to do the analysis. I mean, it's just in the exam hall. So all information will be given in the question. So you just make use but some question perhaps we still require you to think to provide the answer. So you need to understand. So you need to understand about the concept of everything we discussed in this lecture. Otherwise you will not be able to. Everything is on the paper. So no, there's no. It's unlike the midterm test. You get your data for it analyze. Final exam, all the information will be given in the question. So even the use output also given to you in the question. So you just make use of all the unique information to provide answers. Okay. So final exam, you are not allowed to use any electronic devices as well. Okay, you are only allowed to bring in the printed materials. So iPad or whatever, mobile phone cannot. Whether next week, Monday next week, I'm not sure. So, okay, so if that attendance to me, then it's not. Some of you have assigned it. Make sure you shut down computer